Hey folks, welcome back to episode 2 of Building a Fully Functional F# Web API. In episode 1 we developed a hello world, we spiked our walking skeleton, we got it up and running with a bit of fiddling around with async computation expressions. And I promise episode 2 will be less struggling and more productive, because we are actually going to build our first feature. So let's take a quick broad look at what our app will have to support functionality wise, and then let's just dive straight in. Again, this is the book that this series is based on. It's a Kotlin book, but the principles are all in there, and they're the same principles that I will be touching on in this series. Functional stuff. So what will our to-do list app ZI, what does it need to do? Well, we'll have 3 screens to start, and this is my beautiful first screen. It's just an overview of all your lists, a short description of those lists, the status, and how far done you are with those lists. So this is like the list overview page, and then you can inspect one of those lists. You can go deeper. For example, this books list, you have items in these lists, like lists of books, and you have due dates if you want them, so you can have deadlines and pressure yourself for no reason, artificial deadlines, and you can check off. That's the best part of a to-do list app. You can check off items. You can of course edit existing items, you can add new ones, you can create new lists, you can remove lists, stuff like that, but that's the big idea. And then towards the end of the series we will building up towards a killer feature. And this is our killer feature. It will be a screen showing your next up items for every to-do list. For example, my first thing to do is, oh no, I'm 2 days late for my mow the lawn task in my DIY list. And next up is I have to finish reading this book in 2 weeks from now. So this will be a killer feature, but for episode 2, for today's episode, I suggest we just build our backend to do this, to get an overview of lists. And we'll touch upon domain modeling, we'll do some fun stuff. Let me grab my table of contents here. Yeah, let's just dive right in. So I suggest we do this outside in, so we start working from our API outward and then dig deeper and deeper until we hit our domain. Persistence is not something we're going to do right now. It's something we will bolt on in later episodes. Or we're not going to use a database, that's what I mean. We're going to have some state, but if you reboot the app, your state will be gone for now. So yeah, how will we go about building this list page or the list endpoint? Quick recap, we have a simple web app. It's using Giraffe. One of the comments in last episode said that this project is no longer supported, no longer maintained. They are super correct. There's an alternative. It's called Oxpecker. That looks promising, looks good, but I did all my preparation with Giraffe and it's feature complete enough for what I needed, so I'm just going to keep using this one. But if you're building production apps, maybe alternatives, you could maybe take a look at the alternatives. But anyway, this is our web app. All the rest is like plumbing and middleware. But this one line of code here is our Hello World Giraffe web app. And in our tests, we only have big end-to-end integrated tests that build an in-memory server, and we can do gets, posts, we can post all kinds of REST requests or HTTP requests. So I was saying a while ago that we are going to do outside in. So what would it look like to query all the lists for a user? We have not talked about the concept of a user, but that's maybe something we will be introducing from the start. We're not going to do security, but we are going to implement users. So if we're doing outside in TDD and we are implementing a backend, one of the first things you might think about is, what will my external API look like? What will my routes look like? What will my payloads look like? What will my response look like? So let's start thinking about that from a test. from a test perspective. So I'm just going to duplicate this entire test and we're going to clean it up once we have some duplication in there. But for now, let's just copy paste everything. Let's see if this still works. No, let's maybe first give this a better name. Can get all lists of a user. So that's the test I wish I had. I'm programming by wishful thinking here. I tried to run this test, but my shortcut error message sound was coming up. So I hope I can run this test. Okay. So yeah, what would this endpoint look like? What would be the wishful thinking? I want to do a get, but I don't want to get on the root. I want to get on some kind of other route. So let's try and get all my own lists. I am Yo, so I'm gonna put my name in the route. And I'm gonna just get all my lists. So I'm gonna do a get on my username / lists, and that will give me all the lists. That's a string response, I guess. Why is my, oh dear Lord, my IntelliSense is gone again. Okay, there it is. What does get async return exactly? Oh yeah, it's an HTTP response message and we are reading the contents as a string here. I propose we're not going to do strings. I propose we are going to return JSON. Yeah, so let's think about types. My domain will be very much open for discussion, but if we look at what our view model needs, what the front end needs, it's going to be some kind of response containing a list with to-do lists, description of the lists, status, and the percentage done. So for now, let's just define this contract, the first thing we can think of. So I'm going to put my mockups. Oh, that's not what I meant to do. I'm going to put my mockups on one side of the screen. There we go. And I'm going to put my code on the other side. If you look at my background, that's Final Fantasy. I just finished it yesterday. It took me 90 hours, which is too much time, but it's an awesome game. Anyway, I'm getting distracted. So what would our contract look like? I'm going to define the contract in my production code, not in my test code, just because. I'm going to put it here, top level. We will clean up later. No, let's maybe make a new file with a new namespace or a new module. So I'm going to add new file. Can I do this with my resharper shortcuts? Is resharper like F# aware? Let's try. Let's define something and let's extract that. No, resharper does not know how to work with F#. Kind of makes sense. So let's do this old school. Let's add a new file. Yeah, and let's call this contract. This is the contract or REST contract with the outside world. And let's have a type get lists response. How do I declare a type in F#? It's been so long. Is this how I do it? I've been programming in Rust for a while, so now I'm super confused on how I define types. How do I define a record in F#? Oh dear Lord. I have to Google even the silliest things, as you can see, but that's no problem. Equals, and then the mustache operator. Okay. And this is more like it. So what does our response look like? We have a HTTP response. It's just JSON, and it contains a list with an array with our lists. So let's have lists, and it's a to-do list array. So now let's declare to-do list. And it has a name. It's just a string in our REST contract, description as well. It's lowercase. Yeah, it's lowercase. Why not? It's JSON, right? Status. What's the problem here? Do I need to do a comma? Oh, sorry. I have name twice. That's the problem. Okay, so I have a name, I have a description, I have a status. That's already interesting. How are we going to represent a status in our REST contract? In F# you have two different kinds of types. In C# you kind of have as well. You have classes and enums. You have a lot more. You have structure, you have records, but you have like two broad categories. Maybe let's go back to our drawing here. In functional languages, you have two broad categories of types. And people refer to these things as algebraic data types because they are combined from other types. And they are combined in two different ways. So the first way is called product types, which is what you know. It's classes, it's records, it's structs. And that's basically what we're doing right now. Our to-do list is a name and a description. So the list type has like the combination of all possible names and all possible descriptions. So that's why they call these like product types. It's a combination of two things, and it kind of multiplies the type space. Alternatively, the second kind of types in functional languages are called product and sum types. I had to think about this. And where you're kind of multiplying the type space here. In some types, you're not. In some types, you're enumerating stuff. Rust calls them enums. In C# you don't really have, or you have like a basic form. You have the enums, but you don't have like the full-fledged sum types or union types as they're called in F#. But what do they look like? They look like enums on steroids. So they are, for example, what we're trying to do here, our to-do list. Where is our to-do list? Oh yeah, it's right here, sorry. Our to-do list has a status, and a status can be one of three things: in progress, or doing, done. Oh, my brain is not fully awake. So it's one of three options, and that's a very basic use case for union types or sum types. So that's what we mean with sum types. So it's status is either to do or doing or done. And this vertical pipe here, this vertical bar, is how you enumerate the cases of a union type in F#. So those are two different kinds of types. The more familiar product types, and then you have these exotic union types. They just look like enums right now. I am aware of this, but we will start utilizing much stronger forms or much stronger kinds of union types in just a second, or maybe next episode. We'll see how far we get today. Anyway, slight detour on different kinds of types. So now I want this union type to-do list status. It's to do or doing or done. There we go. And every to-do list has a status. What we're doing right now is called type-driven design. So we're not just thinking about behavior too much. We're first declaring our types, and we are making the types as explicit as we can. Of course, we're still building a REST contract, so actually everything is just numbers and strings over the wire. So I'm not sure if this status thing is a good idea, actually. We'll see. We'll see how we get to serialize this over the wire in just a second. But I'm already having my doubts of putting an enum in a REST contract. We'll see how far we get. So we have a response with a list of to-do lists, and every list has a name, a description, and a status. I think we're almost done. Maybe we need one more thing. Percentage done. Yeah, we need a percentage done. Yeah, so let's add that. And let's just make it a decimal. So this is our type. This is what we want to get back. If we have a response type like we do here, we could introduce a request type as well, so you have some kind of symmetry. I see a lot of this in the code bases I work in on my day job, which is a good idea, but I'm not going to do it. Why not? Because I want to pull part of my request from my route. So it will not only be my JSON payload. There will be no JSON payload here. It's all going to be in the route. It's going to be my username and that's it. So I'm not going to bother by specifying a request object. So yeah, this is actually it. So let's start writing this test now. So we have our test server, it starts up, and then we say, okay, give me all my lists. And it should return some JSON. We are going to use our types in just a second. But for that, we need some kind of JSON deserializer, right? What's the modern way to work with JSON? I know it's not Newtonsoft anymore. What's the official system.text.json? How do we convert? This is serializing. How do we deserialize? There we go. How to deserialize. There's like an actual. Okay, it's the same type. Okay, so we need this. Is this something we have to install, or is this available for us? Let's open that up. Yeah, it seems to know this, so that's cool. So let's read this as a stream. So this is now an IO stream, and now we can convert this into some JSON. JSON what was it called? JSON serializer. That's actually a logical name. Hooray. Let's deserialize. Let's go async. Why not? We're going async all the way here. It's a generic, it takes a generic type parameter and a stream. So yeah, let's give it a stream and let's give it the type of our response, which will be a get list response. And that should be in contracts. It's saying the type is not defined, but I can navigate to it. Anyway, I think this will work, and our response is now a get list response type. So this should work if everything is up and running. Now we need to kind of write an assertion here because we're doing arrange act assert. Or actually, we're doing some stupid arranging. We're doing it in a real act, but we're not really arranging anything, right? I hate it when tests have black magic. And if we would just hard code some stuff in the API and like check it here, I don't like a test that is not a full story. So I want to do in the arrange phase here as well. I want to provide some data to my API. So I want to set it up with some data initially, and then I can see in this test, okay, this is the data that's in the backend. I'm doing this call, so this is what gets returned. So we're going to have to shove in some database or some data in my test, and then we can verify that doing this call returns the correct data. And we're just going to hard code the data for now. We're not going to go crazy because next episode will be about adding new lists. So now we're just going to provide like a hard-coded database containing some lists, and that's it. That's everything we're going to give our backend in this episode. How are we going to inject our database into the backend? That's why I love these test server in-memory integration tests. You can just do whatever you want in here. This is just a web host builder with all those middleware and app config things in there. You can inject whatever you want in here. You can inject stuff in the test that's not there in production code, and it'll all work nicely. So that's what we are going to do. We are going to inject some data into our API when it starts up. and that's like the database for now. So let's define our database. Our database is just a map. It's going to be a lookup table. C# as a dictionary, and that's what a map means, more or less in F#. And it will map keys to values. And let's just map users to their... Yeah, let's map users to their lists. So let's literally map my user, and let's map it to a list of lists. And a list can be whatever, but for now, let's just hard code to-do lists. This is a REST type. Is that a good idea? I did not do this REST contract when I was preparing today's episode, and now I'm all kinds of doubtful about how far we will go in today's episode. Yeah, let's not use our REST contract. Let's use our actual domain. Let's start writing some types that are in our domain. So these are my contract types. Let's write a new module called domain, and this is where our domain logic will live. It does not need responses, but it does need to know about to-do lists. And let's keep this pretty similar, but let's introduce some more types, because a name can be any string. Or no, let's not do that. Sorry, let's not do that right now. We will get there when we get there. I am jumping way too far ahead. So yeah, this is a literal copy paste of the contract, which is not very... it does not provide much value right now. And I don't like to do mapping when I see code bases that are full of 3-4 layers of mapping. I go crazy. But there is one layer where I kind of understand where mapping makes sense, and that's when you have a REST contract or something like that. That's the external world. It's a contract with the external world. You have to be very careful about evolving that API, evolving those types. That schema is like published, so that's why I like to keep my domain and my contracts to the outside world distinct. And for now they are identical, but I promise you they won't stay this way for long. But for now, yeah, we have a domain which contains to-do lists. It does not contain items. We don't need that for the first screen, so let's not add items. It's just the name, a description, and a status. Cool. But now we're going to use these domain types to put stuff in our database here. So let's call this lists, and I'm gonna provide some type hints here because we have two definitions of to-do list. And if I type it explicitly, the compiler won't get confused about which of the two types we're using here. So this is a list of to-do lists. It's an array, sorry. Let's do it list. I like my lists. There we go. And this can go in here instead of the empty list. Now we have a database. The database is empty, or it knows about me, but it has no items. So let's add a to-do list. What will now I'm thinking about, we're doing the arrange now. The assert will be tricky if I have a different type in here, or we're gonna have to do more work ourselves. But that's not a problem. Let's introduce a name. Let's call this my books, description, my bookshelf. Oh, I'm using the wrong delimiters again. Oh no, and now I am completely confusing my... why is this happening? Oh yeah, because I have not given it every field. It needs a status and it needs a percentage done, something like that, right? I would like some IntelliSense help here. Why is it not hinting at what I need to do? I don't know. So let's give it a to-do status. And percentage done. It's super strange, right? It's not It's not auto-completing anything. It's just crashing with a compiler error. That's great. That's great. So it's 0% done. To do is not defined. Oh yeah, I have to open that module, but we can fully qualify it. There we go. So we have a list, a single list, and we're putting it in. That's our database. Let's now insert it into our backend. This is ASP.NET, but this zi.configure thing, if you remember, that's something we do. This is where we configure our IOC container and where we configure our app. And if you take a look at our app, this is actually using that function we defined. So this is our API. We need to get our database as far as here. And you could use something, you could use the ASP.NET service collections, the dependency inversion injection framework you know and love from ASP.NET. But I'm not going to do that. I'm going to use some functional principles. And I'm just going to feed in the dependency, extra argument to my function. So this configure function right now takes a web host builder, this thing here. Let's also give it a database. So this thing next to a web host builder also takes a database. There we go. This should compile. It compiles. So now we have a database in here. Where do we need to give it? Configure app needs to know about it. What is configure app? Again, it's a function that takes an application builder, but we can also give it a database. And if this function expects a new argument, a database, there we go. We just injected the database. And we can go one more level deeper. Our web app needs a database. So we give this web app function a new argument. And that should also work. There we go. So now we have a database in our own code and we can work. How this is technically working, because if you look at this thing here, configure app DB, it's something weird, right? If you write a lot of C# and not a lot of F#, this looks super weird because it's a function and this function takes two arguments, as you can see, a database and an app. But right here, we're just like giving it one argument and the compiler is happy. What gives? What's happening? This is a concept called currying or partial function application. And you can give a function one or many or a couple, but at least one. You can give a function one of its arguments, not a complete argument list. And that actually will kind of return a new function that takes the remainder of arguments. So this is a way of building functions out of other functions by pre-filling in some arguments. And that concept is called partial function application. And that's exactly what we're doing here to feed in this database argument while still accepting all the other arguments that these functions take. That's also why I put the database first, because now in a partial functional application, I can put this database argument in there and all the other arguments that come after keep working the way they did. So now we have a database in there and now we can query and now we should get something and it should be a contract get list response. So I'm just gonna make sure we have our test up and running. So that's a record and the record type has lists and that's an array of to-do lists. This should all compile. Yeah. And let's now expect this entire to-do list. It's a different type because it's the contract thing, but I kind of expect something like this to come out. Yeah, I'm kind of happy with this. And this is where unquote will help us. If one of these properties is incorrect, it'll show that instead of like blowing up in some weird thing. You can write very coarse-grained assertions with unquote and still get to the heart of the matter. So let's watch this test fail. Oh, let's watch our compiler fail. That's interesting. Oh yeah, our first order of business. We changed one test, but we did not change the other test. and our zi.configure function takes a database, and we failed to provide a database here. So let's give it a map.empty. Let's give this test an empty database. That should work better. There we go. That test is green again. Our app still bootstraps, but now we have a failing test saying that the input does not contain any JSON tokens. So if you take a look at what's happening, we are trying to parse our content, I'm guessing. Yeah, it's a JSON exception. We're trying to parse this result, but it's probably not giving us JSON. So let's debug. You can put a breakpoint in here just as you could with C# code. And let's debug this test. Let's take a look at what we're getting back. What we're doing now is we're still in the red phase of TDD, but we're gonna make the test fail with an error message that makes sense. So our stream is a memory stream. Oh yeah, we cannot really inspect the memory stream, but we can expect the response. It's a 404 not found. So that makes sense. Can I write an assertion in there? So can I do a test response dot result code, status code? Can I do a 200? What's this? Systemnet HTTP response message. Not found. Okay. Oh, it's systemnet HTTP status code. Sorry. It should be an okay, right? So now this test should fail, saying, hey, I'm expecting a 200, but you're giving me a 404. There we go. So that's a smaller step. That's okay. Okay, so this means that our backend does not know what to do with this route. It does not understand /yo/list. Let's make it understand. So we're going to introduce a new route. This is the main route, our index, and we are going to add a new route, and it's just another element in this choose argument we feed to this choose function from Giraffe, and it's going to be the exact hard-coded route. There's one variable in there, my name, but we can get that out in just a second. Because it's still not working. That's actually, I was calling my shots here. I was expecting HTTP 200 at least, and it's still saying no. Oh, it's /yo/list, of course. Does the forward backward slash matter? Yeah, so it's saying H is an invalid start of a value. I'm guessing it's this H, so I'm guessing we're hitting our endpoint. The only thing I want to do before we proceed is get rid of this Joe, get rid of my name. I want to put that in a route variable. So let's look that up. Can we extract stuff out of a route? We have to, right? All hard-coded routes. Where are routes with variables? Oh, I knew it was something like this. So you have the route f function, which is what we need, because you can provide like arguments, and then you can use those arguments in your request handling function right there. So we're going to use route f, and you can use you can extract bools, characters, strings, integers, GUIDs. You can extract whatever you want from a route if it's a basic type like this. So let's try and extract a string. That's what we're doing. So I need this in my format string. So, and my handler function now needs to take an argument, and that is the thing that's in that route f call here. So this string variable here will be piped into that user over there. Yeah, that's correct. But I don't know where this fish operator came from. It has to go for a second. Okay, this compiler is, or my IntelliSense is super slow. I always think that I'm doing something wrong, but actually I'm not. It's just a slow compiler. So this test should still fail for the age. And it is. And now let's abuse this and let's pipe our username back to make sure that works. So now I expect an error saying something with my J, my first letter. Yeah, so J is an invalid startup value. Okay, we're getting there. We have a route and we have a handler or some code we wrote that is handling this request. And we are extracting our username as well. So we're super duper close. I think we are there. The only thing we need to define is our database. This thing has to query the database and then convert our response to JSON and then send it out. This is we know in our test we just injected a map, but I don't want to bind my business logic or my HTTP logic here to the fact that this is a map. Because it's in the name functional programming, I would prefer functions. I would prefer something, a dependency for my web app that just takes a username and can like return the list of to-do list for this user. So actually DB was a bad name. I just want to kind of have a function that given a user returns a list of books, or sorry, a list of to-do items. So let's drop back to our domain. These are the types we had. Let's now introduce a function type. Functions can also have types and you can declare them just as you can with the records and union types as you see here. So let's declare a function type and let's call it a list fetcher. And it's a function. Function type is this arrow thing and the arguments or the input goes first and the output goes after the arrow. So we want something that takes a string and returns a list of to-do lists. Why is this? Oh, to-do with a big D? No, let's keep it small. To-do list. So let's fix that in our tests as well. There it is. Okay, so I am declaring a new function type here saying this list fetcher type, it's a function that takes a string, which is their username, and it returns a list of to-do lists. A list, not an array. I don't like this string everywhere, but I promise you we'll get there in the next episode or so. We'll clean that up and make the user first-class citizen in our application and not just have strings everywhere. But I'm digressing and we're already running 40 minutes, so let's keep pushing on with our first feature. So if my DB here doesn't have to be a map, it can be anything that can transform strings into lists of to-do lists. So let's call this list fetcher. And this thing now can query our lists. Okay, cool. What is this thing? Oh yeah, this thing also needs a database. Oh yeah, and it doesn't need a database, it needs a list fetcher. So it needs a function, not a fin, but a fun, that takes a username and it returns the list of to-do lists for this user. Is this not how you declare a function in F#? Okay, it is. I'm starting to doubt everything I'm doing here. Okay, so this is actually our list fetcher. So let's maybe extract that. Extracting by hand because ReSharper does not work for F# code. I really have to give Writer a try. If you have experience with Writer, would you recommend it or not? Is it worth the money? Please let me know in the comments below. Anyway, so we declare our type, our program is compiling, but our tests are super hard blowing up because we need this list fetcher here as well. I'm just gonna grab it for now, this lambda, this anonymous function, and I'm just gonna feed it in. For our test that we're writing right now, I kind of do like to see this or this map in here. It's very clear that this is the input, this is the database. So I am going to use this map because it's very clear in the arrange phase of my test. This is the data. I do something and I get it out. But we need a list fetcher for our code. So how do we do that? We're going to wrap our database inside a list fetcher. So let's create a list fetcher that works on maps for now. And we will be using that fetcher in our production code as well. Maybe if we hard code some data with maps as well. But I'm getting way ahead of myself. So this is a fetcher that takes a username and it returns a list of to-do lists. And we can now pipe that in here. So this should all compile. Let's maybe verify that real quick. Yeah, okay. And now let's implement our map-based fetcher. So I'm going to call this fetcher that works on maps, and not just on any maps. It works on our map, this DB. So it'll just do a DB map.find of the username, and that's it. So it's just a map lookup. But my production code doesn't know. It just knows about list fetcher function type, and that's it. My main method knows something. It provides this fetcher, and my tests know something. It provides a different kind of fetcher, or the same kind. Yeah. Probably in production we'll run against a Postgres database or something, and in our tests we'll keep running with something in memory like our map here. That makes sense for me, because it keeps our tests really fast and snappy for all those tests that run that verify our functionality. Of course, you need some tests that run against an actual database for the database integration and the mapping, but my tests that verify functional behavior, domain logic, stuff like that, I don't want my database slowing those down, especially not for large applications. So let's run it and see how far we're getting. We're still having problems because we're not returning much, but at least it compiles. So we're taking big steps here. We're not really doing micro test-driven development, but I'm still comfortable with how we're proceeding. So I'm just gonna forge on ahead. We have a user, we have a list fetcher here. Let's call it fetcher maybe, and let's call it fetcher everywhere. I wish I had automated refactoring support. There we go. So we have a fetcher and we have a username. Now let's define our first actual business logic, which is super silly because it'll just be a function call. Let's extract this into a variable. Get lists for user handler. Hey, where did my copy paste go? I'm extracting a function, but it's not really. Oh yeah, that was actually the one. Okay, cool. I was expecting this to compile. Okay, it is compiling. And we can inject the fetcher as well. Again, it's partial function application, sorry. There we go, everything compiles. And we have a separate function that's super clean. It's isolated from its context. You can unit test the snot out of this, no dependencies. But it's not really super interesting because we're just gonna fetch the list for a user. And we're gonna return those as JSON. I think you can just say JSON. And we need to map that, of course. Lists is a... What's the problem here? String does not match the type HTTP func. Sorry, is it because I'm injecting and I'm having user here? Yeah. Where is my user? There we go. Okay, so this is now returning JSON. But we still need to map our to-do lists to our contract types, right? Now we're not mapping to our contract types, and we're just returning our domain types, which is one of the few mapping no-nos in my book. So let's map those lists. I'm going to help the compiler here. It does not know what this is. And I kind of need to know because I want to map over my to-do list types. And now it knows, okay, this is a list of to-do lists in the domain module. So now let's map this to to-do lists in our contract module. I'm just going to write a new function in the contract module. So let's declare a function here from domain, sorry. So it's a function that takes a to-do list from the domain and it returns a to-do list. Okay, it was very slowly compiling again. So this is now a list of units because I return unit, nothing, but I want to return a contract to-do list, which is literally this thing. People tend to use automapper here. I tend to really hate black magic in my code, so I don't mind writing handwriting some mapping logic like this. And this is a domain to-do list. And it has a description. My formatting sucks, but as soon as I hit save, my auto formatter will take care of everything, so it'll be okay. Mapping a status is a bit more tricky because it's from a union type to another union type, but list.status, no? Does my domain not have a status? It definitely has. And it has a map status. Oh, it's because I'm not using an equality operator here. Okay, cool. I should. Okay. So now we need to define this map status. I'm going to write an inner function. And I'm going to pattern match. This is the first time we're going to pattern match. And it's why union types or enums on steroids are very powerful. We're not going to see the full power, but we're going to see our first pattern match here, which is basically a statement enumerating all the cases you want to, all the interesting cases, and declaring like this should happen in that case, this should happen in that case. And if it's not exhaustive, your compiler will say like, hey, incomplete matches, as you can see here. You're not exhaustively matching. There are cases that are not covered. You will have runtime exceptions. So that's what makes pattern matching powerful. But for now, it's mapping to do to and to do. But it takes a status, which is a domain status, and it returns a contract status, which is this module, so it's the self. And it's a return type, sorry. Okay, you can, okay, what's it saying? Oh yeah, it should now, we have this S argument here, and I was using this function syntax. That works if you don't define the argument, but because I want to give it a type, I need to use the match syntax instead of the function syntax. It's syntactic sugar is the same thing, but now I can explicitly type this S variable or this S argument. Why is this still red? This expression was expected to have domain status, but here's type status. No, it does not. You think it does. This is what I want. And now I wait 10 seconds until my compiler, okay. To do, what are the other two? doing, and done. You could spend 20 minutes writing unit tests for this, but it's so explicit and so clear that I'm not even going to bother. This reads, I can just give it an eyeball and it looks correct, so that's good enough for me. I don't even need test coverage on this. Famous last words. Where were we in our API? Where is our API? It's right here. So we have something that fetches a list. We return our mapped lists, which is our REST contract, and we just serialize this to JSON using the default serializer from Giraffe. Is it good? We don't know. Is it using the system.text serializer we are using to deserialize? I don't know. Is that something we should look up? Definitely. So let's take a look at how Giraffe serializes JSON. Oh, I saw system.text. So JSON, by default, Giraffe uses Newtonsoft. No! Let's not do that. Let's use system.text. To use system text JSON serializer instead of Newtonsoft, register a new dependency during application configuration. So this we know, we use this to register services, register middleware, and I see some add singleton magic here in our configure services. Let's do that. Configure services is right here. So this is what we're looking at. What did the snippet look like? We create options. We add a converter. Oh no, that's for union types. That's optional. I think it's not optional because we have a union type in there. We'll figure that out in a second. But this is the one we need, right? This add singleton thing. Okay, so we have an add singleton, and this entire line is what we need. And JSON.serializer, and we need those serialization options, which can just be the default options, sure. So now we just configured a Giraffe to use the, or is this the Giraffe namespace? Yeah. So now we told Giraffe, hey, you have to use this serializer, not the Newtonsoft one. It's super weird that it's using the Newtonsoft one, right? That kind of shows how old Giraffe is, or how it lost its shine. It's not keeping up with .NET anymore, I think. Anyway, there we go. So we're almost there, except I introduced a union type in my REST contract, and it's biting me because F# discriminated union serialization is not supported. What is throwing this error? What knows about this? Not supported exception. Where is this coming from? Oh, it's coming from the system.text namespace. That means like there's code in here that kind of knows about F#, and it knows enough to say it's not supported. That's funny. Why don't you just serialize it then? Okay, no. Let's use this NuGet package, which is an addition to the system.text.json namespace. So it works nicer with F#. So let's install this package. We need to serialize it. So our production code needs to know about this, but we also need to deserialize it. So our tests need to know this. And I'm very curious at how this looks as a string over the wire, because not every client is an F# client. And that's maybe why I would not recommend putting union types in your REST contract. But just for fun, I'm going to do it anyway and see how far we get. So let's browse for this NuGet package. And let's install it in our tests and our production code, because we need to serialize and deserialize. There we go. Should still build, everything should still compile. It is. So now let's add a converter to our options. Our options are right here. So now we do need to extract or change those options. So let's grab these. JSON options. Let's extract it into a variable. Okay, and now let's add a converter. That's not a very functional way to add a converter. Can I not use record with syntax? Let's figure it out in a second, but let's get this compiling first. I'm just going to take a look at this converter. It's where is this defined? Default options. Why am I bumping to the giraffe disassembly? That does not look correct. Oh yeah, actually, right there. It's system text, it's a type, it has some functions, it has members. Yeah, it's not really a record type, so we won't be using anything cooler. So that's a bit more messy, non-functional code. Let's just close this up. Okay, there, it's gone. It's gone. As you can see, there's a bit of messiness still because we are running on top of Kestrel. We're using configure service, configure app, and that is still not very functional. The API, I mean. Value could not be converted to contract get list response. Sorry. Now it's starting to lose me. What is it saying? Oh, it's actually already hitting the deserialize. Interesting. Now I'm starting to get curious about what is actually being returned. Last episode we had a play with the HTTP file where we could send requests by just pressing a button. It's like a poor man's alternative to Postman. And I'm gonna write a query or a GET request to our current endpoint to see what we get back actually. But before we do that, we kind of need to seed our system with some data, because right now our database or our fetcher always returns no lists. Let's hard code a single list. And let's use it exactly the same list in our tests, which is this bad boy here. So this is a to-do list. Let's put it in our production code. So every user that logs in now has a my bookshelf as a single one and only list. I'm sorry, world. This is a fetcher. Let's make this explicit. There we go. This does not look correct. This does not look correct. What happened here? Configure web host defaults. That does not. This line does not look correct. When did we introduce this one? Oh. Where did that come from? Configure, that's what it needs to happen here. Where did configure go? It takes the configure action, which is this function. Where did that function go? Have we been flying red for this long? Okay, that's better. App bootstraps correctly? Now I'm not too sure now I saw this problem. Let's run our app, make sure it still bootstraps correctly. Our test is running a lot of code except the main method. We are running like a slightly different version from the main method, so we're gonna run a quick end-to-end test using our HTTP file here. Let's see what gets back. Hello user. Okay, we're still running. It's still good. Cool. So we can proceed and add our data. We have now a single list database. For every user, we get a single list. Let's now query it end to end. So let's write a new query in our HTTP file. I think you can delimit using 3 bangs. Yeah, there we go. And we want to call me/mylists. And that should give me my books. Let's see if that works. Yeah, so it's returning stuff and it looks super cool. Why is deserialization failing? Oh, I know, the penny is dropping. So this works. This looks exactly the way I would expect it. Do we have a 0% done? Yeah, and it's to do. Yeah, that looks correct. So what's going wrong in our tests? Same thing we had to do in our production code. We configured this JSON serializer. We have to do this for our tests as well. So I'm guessing JSON serialize or deserialize, you can provide options. You can provide options. So that's what we need to do. It's the same options, right? I'm gonna extract those from my production code. So these are the options. These are the options. Let's just define a variable for that. There we go. And return JSON options. So those are the options we need in our production code, but also in our tests. It's serializer options, sorry. There we go. So that works. Was JSON options a better name? Yeah. I'm gonna rename everything a bit, make it make more sense. Okay, so now we have a function or a variable called JSON options, and we can actually use that one in our tests as well. So I'm guessing if I provide my options here. So as you can see, this first big end-to-end test, our walking skeleton had some kind of integration test, but if you start working with JSON and stuff, the first test I write is always, as you can see, an hour long. But once you have one of these down and you extract some helper functions, stuff will start flying way faster. This is the first bump. And we're not here to build the fastest or to code the fastest API ever, or to do it in the least amount of time. We're here to learn, right? Hey, we're there. The only problem is that we are returning an array and not a single. Failed to parse get list response. Expected the JSON object found start array. That's actually good that my test is saying this, because I totally forgot that our route or our end handler should return a response object, a response record, not an array of lists. It should return this bad boy, get list response. Was it not lists? It is lists. It's a contract type, so it's in the contract module. There we go. And we should serialize our response instead. Mapped is an array, but has type list. I kind of have to start making up my mind, no? Do I want to work with arrays or lists? On my REST contract, I want arrays, so I'm just gonna convert to an array here. So this is the to array of C#. There we go. I'm kind of hoping we get to green. We are getting to green. So that's our first feature done. We hard-coded the database. We have some types in there, and I am very unhappy with where we are, which is awesome because now we have a lot to clean up. 1 hour is long enough, I think, for an episode. So I'm gonna cut the stream here, but I'm gonna outline my plans quickly and do a quick recap. What are my plans for the next episode? I'm going to clean up my mess. Let's take a look at my mess. Starting from the tests, maybe. I just copy pasted the hello world test and started working on it. There's a lot of duplication here, so that's something I want to clean up. This test does not read like a book. There's a lot of noise between the relevant signal. So what do I want to see in my test? I want to see what data is in my system. I want to see what call I'm doing. And I want to see what result I get, but I don't want to get bogged down in all these async, JSON, serializer details. That's irrelevant. Let's get rid of that next time. Next, let's dive deeper. Then we wrote the implementation, which was adding a route to our functional web app. And this is the new handler, the new function that activates on this route. It takes a variable from the route, the username, and then it just looks it up in the database. We abstracted the database by using this list fetcher type, a function type. And we injected it functionally by doing partial functional application and not using a dependency or an IOC container as we are used to in ASP.NET and object-oriented languages. This function is pure, it's side effect free. So it's super easy to unit test. Did we? No, we did not. But in theory, it's super easy. I was thinking, does it use JSON serialization? Yeah, it uses it on line 14. So maybe I would get rid of that. Depends on what you want to test, I guess. But this is the principle. Writing pure functions, extracting the business logic in a domain and like super testable, super dependency-free things, and injecting everything you need as a function. A function can be a dependency as well. And if you look at my domain, it's nothing. It's just a bunch of types. So the heart of our logic is these 4 lines. Not much to do about nothing, but we'll get there in the end. So next time we clean up our mess. And this time we built our first feature. We can get a list of users. I hope you learned something, and more important, I hope you had fun. Hope to see you next time. Bye-bye.